Hi everyone. In this video, I'm going to be talking about Lewis structures and formal charge. In the last video, we have discussed about something called the octet rule. Okay, the octet rule is a theory put forward by Cossell and Lewis, which basically tries to answer one of the most important questions: that why do atoms even combine to form molecules? Okay. This theory is based upon the fact that all the atoms are trying to achieve something which these noble gases have, which is 8 electrons in the valence shell, and we call these 8 electrons in the valence shells as octet. And all the elements in periodic table are only trying to achieve this octet configuration so that they become just as stable as the inert gases, and that is why bonds form. In special cases with hydrogen and lithium, these two elements are trying to achieve the noble gas configuration of helium atom, which is basically 2 electrons in the outermost shell, which is also called a duplet. The point being that all the elements in periodic table are only trying to achieve 8 electrons in their outermost shell, or in some cases 2 electrons in the outermost shell, by give and take of electrons, which is forming ionic bonds, or by sharing of electrons, which is by forming covalent bonds. Now, since this theory only talks about the number of valence electron that an atom has, okay, Lewis suggested a representation in which we can represent various elements with respect to number of valence electron that they have. For example, hydrogen is having electronic configuration of 1s1, okay. It has only one electron in the valence shell, so hydrogen can be represented by this. So the small dot represents one electron in the valence shell of hydrogen atom. In case of sodium, we have electronic configuration as 1s2, 2s2, 2p6 and 3s1. Again, the third shell is the valence shell, and again it has only one electron in the valence shell. So sodium also can be represented with only one dot, which represents one electron in the valence shell of sodium atom. In case of carbon, on the other hand, the electronic configuration is this. Okay. Here we have 4 electrons in the valence shell, so carbon can be represented like this with 4 dots, which represents 4 electrons in the valence shell. In case of nitrogen atom, we have electronic configuration as 1s2, 2s2 and 2p3. We can represent it with 5 dots, which represent 5 electrons in the valence shell. In case of oxygen, we have 1s2, 2s2, 2p4. Okay. Now we have 6 electrons in the valence shell, so oxygen can be represented by 6 dots, which represents 6 electrons in the valence shell. So according to the octet rule, the atom wants 8 electrons in the valence shell. Okay, so either by give and take or by sharing, it has to achieve 8 electrons, or in case of hydrogen, 2 electrons in the valence shell. Now in case of hydrogen, what it can do is it can share its one electron with another monovalent atom, which means an atom which is again ready to share only one electron, let's say another hydrogen atom, and that is how a covalent bond is formed between two hydrogen atoms. Okay, so both these two are having one electron each, and they want to achieve a duplet, which means 2 electrons, so they will just share these 2 electrons with each other. Okay, and that is how a hydrogen single bond hydrogen, where a single bond represents a sharing of 2 electrons, is formed between 2 hydrogen atoms, right? In case of sodium, on the other hand, we need 8 electrons in the valence shell. So that can happen if this 1s or 3s1 electron is somehow moved out of the system, okay? And that can happen if sodium forms an ionic bond in which it is giving away its one electron and is now left with a total of 8 electrons in the valence shell. 6 plus 2 is 8 electrons in the valence shell. And that is why sodium forms ionic compounds and not covalent bonds, because it is getting 8 electrons by giving away its electron totally, right? Now in case of carbon, as you can see, carbon is having a total of 4 electrons in its valence shell. It will be quite difficult for carbon to gain 4 electrons or give away its 4 electrons, right? So that is why carbon actually shares its electrons with 4 different atoms, or basically it needs to form 4 bonds in order to have 8 electrons in its valence shell. So carbon forms 4 bonds, okay, to achieve 8 electrons, and that is why in case of, let's say, methane, we have carbon which is having 4 electrons sharing the other 4 electrons with other hydrogen atoms, or any other monovalent atoms for that matter, okay, again having one electron each, and that is the Lewis dot structure of methane. So all these shared electrons belong to all the atoms in between which they are being shared. Okay, and this is the Lewis dot structure of methane. So every hydrogen is having a duplet, which means 2 electrons, and the carbon atom is now having 1, 2, 3, 4, 5, 6, and 7, 8 electrons, and that is why methane is a stable species according to the octet rule. Okay, so basically the point is that carbon needs to form 4 bonds. Each bond represents sharing of 2 electrons. In case of nitrogen, we have a total of 1, 2, 3, 4, 5 electrons, and it needs to form 3 more bonds in order to get 8 electrons, right? Similarly, in case of oxygen, it has 1, 2, 3, 4, 5, 6 electrons, and it needs to form 2 more bonds in order to get 8 electrons in its outermost shell. So as already seen, nitrogen needs to form 3 bonds, which means in case of ammonia molecule, let's say, nitrogen is having a total of 5 electrons in its valence shell, and it needs to form 3 more bonds, or it needs to actually have 3 more electrons in its valence shell to have a total of 8, right? So it's going to form its bonds with hydrogen atoms, 3 hydrogen atoms rather, and now this is the Lewis dot structure of ammonia molecule. As you can see, every hydrogen atom is having a total of 2 electrons or duplet, and the nitrogen atom is having a total of 8 electrons. So this molecule is also stable by the octet rule. Now these 2 electrons, as you can see, are not shared between any hydrogen atoms, right? So these 2 electrons are localized at only the nitrogen atom, and that's why we call them lone pair electrons. Okay, so they are lone pair, which means they are only present on the nitrogen atom and they are not used in any kind of sharing, whereas these 3 electrons, okay, have been shared with the 3 different hydrogen atoms. That is why they are called the bond pair electrons. Okay, so we have 3 bond pairs and we have 1 lone pair electron here. Similarly, in case of oxygen, we have 6 electrons in the outermost shell, so it needs to complete 8 electrons by sharing 2 more electrons or by forming 2 more bonds. Please note that here we are only talking about the covalent bonds, and we are not talking about any ionic bond, because we are talking about sharing of electrons only. Okay, so oxygen is going to share 2 more electrons, and for that it needs to form 2 more bonds. Let's say it forms another bond with oxygen atom only. So both the oxygen atoms are having a total of 6 electrons, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and both these atoms are going to be having its 8 electrons complete. I'm sorry for the way this picture is being made, but I hope you understand the meaning. Okay, so it's having 1, 2, 3, 4, 5, 6, 7, 8 electrons, and this also is having 1, 2, 3, 4, 5, 6, 7, 8 electrons, and that is why we have oxygen, double bond oxygen, because oxygen needs to form 2 bonds, right? Where each bond means a sharing of 2 electrons. Now, to be very clear, we can understand how carbon is having a total of 4 electrons and it needs to get 8 electrons, and for that it forms 4 bonds. So whatever is the number of electrons it requires, that is the number of bonds it should form. Okay. Nitrogen, on the other hand, is having a total of 5 electrons, 1, 2, 3, 4, 5, and it needs 3 more electrons, so it is going to form 3 covalent bonds. Okay, again oxygen is having a total of 6 electrons, so it needs 2 more electrons, so it needs to form 2 more covalent bonds. So we have seen how whatever is the number of electrons the atom requires, that is the number of covalent bonds it should form. Okay. Now, in case of nitrogen, it is going to form 3 bonds. So if nitrogen is forming 3 bonds with nitrogen or with, let's say, hydrogen or whatever, okay, that is great. That is something which should happen in the normal case scenario. But if somehow nitrogen is forming 4 bonds, because it can form, right? Because we know that nitrogen is having one lone pair which is present on nitrogen atom, which is not taking part in any bonding, and it can also take part in bonding if it is also involved in bonding, and then in that case nitrogen is going to form 4 bonds, and if that happens, nitrogen is going to get a positive charge because it is forming one extra bond than what is required, so it is going to get 1 plus positive charge. Okay, and this positive charge is called the formal charge of nitrogen atom. In case nitrogen forms any less than what is required, which means 3 are required, if it is forming 2 bonds only, in that case we get a negative charge on nitrogen atom because now we have one extra electron free. If we are only forming 2 bonds and only 2 are required in bonding, one extra is left out, okay? And we have a negative charge, and this negative charge is called the minus formal charge of nitrogen atom. Similarly, in case of oxygen atom, as you can see, it should form two bonds. Oxygen should form two bonds either with oxygen atom or let's say with carbon atom. Okay, so whatever the number of whatever atom it forms bonds with, it should definitely form only two bonds. Okay, if oxygen is somehow forming three bonds, because again oxygen can also form three bonds because it is having a total of two lone pairs left out. Okay, which are not taking part in any bonding. So if it is forming one extra bond other than two, it is going to get a positive formal charge. Now, having understood what is the physical meaning of formal charge, let's talk about the mathematical formula for finding out the formal charge. So mathematical formula of formal charge is number of valence electrons in free atom. Free atom means when it is in the not bonded situation, okay, minus number of lone pair electrons minus half the number of bond pair electrons. Okay, so I hope it's clear to us. With an example it will be even more clearer. So we have an example of ozone molecule. Ozone molecule, we have three different oxygen atoms and we have to find the formal charge on each oxygen atom. Okay, so oxygen atom 1, oxygen atom 2, oxygen atom 3. With the physical definition which we just studied, we understand that oxygen should form two bonds in normal case scenario for it to have a zero formal charge. Okay, so oxygen 1 is forming two bonds, which is the normal case scenario. So oxygen 1 should be having a zero formal charge. Okay, oxygen 2 is forming 1, 2, 3 bonds. Okay, 1, 2 and 3 bonds, which is one extra than what should be normally there. Okay, so oxygen 2 should be having a +1 formal charge, whereas the oxygen 3 is forming just one bond, which is one less than what should be normally there, which is two bonds. So oxygen 3 is having a -1 formal charge. Now to find out the same answer with respect to the formula, we have in case of oxygen 1, okay, number of valence electrons in free atom. So in case of oxygen atom, the valence electrons are always 6. So 6 minus number of lone pair electrons. So lone pair electrons in case of oxygen 1 is 1, 2, 3, 4 electrons, right? So 6 minus 4 minus half into number of bond pair electrons. So the oxygen 1 is actually forming two bonds, which means 1, 2, 3, 4. So 4 electrons are actually involved in bonding. So we have multiplied by 4. So we have 6 minus 6, 0. So 0 is the number formal charge in case of oxygen 1, which we have already understood by the physical definition, but I think it is important to understand by mathematical definition also. In case of oxygen 2, okay, the number of free valence electrons remains the same in the free atom minus number of lone pairs. So lone pair for oxygen 2 is only 2, okay, minus half into number of bond pairs. So actually now the bond pairs is 1, 2, 3, 4, 5, 6. So because it is forming 3 bonds, right? So we have 6 bond pair electrons. So this is here, and we have 6 minus 5 is 1 or +1. So oxygen 2 is forming a +1 formal charge. In case of oxygen 3, we have 6 minus, here number of lone pairs is what? 1, 2, 3, 4, 5, 6. Okay, so 6 minus half into number of bond pairs. So because it's forming only one bond, the number of electrons in one bond is always 2. So it is 2. Okay, so it is 1. 6 minus 7, it's -1. Okay, so this is how we can find out the formal charge on any given atom in any given molecule using this mathematical formula. If you have any doubts in this video, please comment that down below. I'll try to answer that. So for more videos like this, keep watching. Thank you so much.